And if I ask you why it doesn't fall, you'll give me an answer almost immediately. It's in orbit. Everyone knows that. You learned it in school. You've heard it 100 times. It's one of those facts that just lives in your brain as settled, done, explained. So let me ask you something. What does orbit actually mean? Not the word, not the label. What is physically happening up there right now that keeps the moon from crashing into us? Most people pause here. They say something like, well, it's moving sideways, so it doesn't fall. Okay. Why doesn't moving sideways cancel out the falling? What's the mechanism? You can feel it happening, can't you? The answer starts to get slippery. The more you press on it, the less solid it becomes. Because here's what you've actually been doing your whole life. You've been carrying a word around and mistaking it for an understanding. Orbit. It sounds like an explanation. It isn't. It's a description of a path, not a reason for the path. And the reason, once you actually see it, is so strange, I mean genuinely strange, that it's going to make you question everything you think you know about falling, about motion, about what gravity even does. Here's the thing nobody tells you plainly. The moon is falling right now. As you read this, it is actively, continuously, relentlessly falling toward the earth. It has been falling for 4.5 billion years. It will keep falling long after every human being who has ever lived is gone. It never stops. It never hits. It just falls forever. Now, that's not a metaphor. That's not a poetic way of describing an orbit. That is literally, physically what is happening. The moon is in free fall and has been since before life existed on this planet. If that doesn't immediately strike you as the strangest thing you've heard today, you haven't really let it land yet. Isaac Newton, he also understood that the way to solve it wasn't through equations first. It was through imagination. So here's the thought experiment he built, and it's so clean, so brutal in its logic, that once you see it, you cannot unsee it. Put a cannon at the top of a mountain, not a regular mountain, a mountain so tall it punches above the atmosphere, so there's no air resistance, nothing to slow anything down. Now fire the cannon horizontally. The cannonball flies out and immediately starts falling. Gravity doesn't care that it was fired sideways. It pulls the cannonball down from the very first instant. The cannonball traces an arc and hits the ground some distance away. Now fire it harder. It flies farther before hitting the ground, but it still hits the ground. Same arc, bigger. Fire it harder still, farther, bigger arc, still hits the ground. Now here's where Newton's brain did something extraordinary. He asked, what if you fire it hard enough that while it's falling, the ground curves away beneath it at the same rate? The cannonball is falling, yes, constantly, always, but the surface of the earth is round. It curves. And if the cannonball is moving fast enough sideways, by the time it has fallen a certain distance, the ground has also dropped away by that same distance. The cannonball never gets closer to the surface. It falls and falls and falls, and the earth keeps curving out from under it, and it never arrives. That's an orbit, not an escape from gravity, not a balance between gravity and something else pushing outward, just falling perfectly, endlessly, with enough sideways speed that you keep missing the thing you're falling toward. The moon isn't held up. The moon is aimed. It was set in motion at the right speed in the right direction billions of years ago, and it has been threading that needle ever since, falling toward us every second, and every second finding that we've curved away just enough. What you thought was stillness is the most elegant miss in the history of the universe. Picture this. The moon is falling, perpetually missing, curving around the earth in an endless arc. Beautiful idea, but an idea isn't physics. So Newton did something that should have been impossible. He took two facts that had absolutely nothing to do with each other, and asked if they were secretly the same thing. Fact 1. On Earth, objects in free fall drop 16 feet in the first second. That's it. Drop a rock, drop an apple, drop anything. 1 second, 16 feet. Galileo measured it. Everyone agreed. Fact 2. The moon is roughly 60 times farther from the center of the Earth than we are, standing right here on the surface. Now, Newton had a suspicion. He thought gravity might follow an inverse square law, meaning if you double the distance, the force drops to a quarter. Triple the distance, it drops to a ninth. The force shrinks by the square of however much farther away you go. If that's true, then at the moon's distance, 60 times farther out, gravity should be 60 squared times weaker. 60 squared is 3,600. So, the moon should be falling toward Earth not at 16 feet per second, but at 16 feet divided by 3,600. Do that calculation. 16 divided by 3,600 is roughly 1/20th of an inch per second squared. Now, Newton checked that against the actual observed motion of the moon, its speed, its distance, the geometry of its orbit, and calculated how far it actually falls toward Earth each second. 1/20th of an inch, exactly. The same number. Two completely independent measurements, one from dropping rocks in a field, one from watching the moon cross the sky for centuries, landing on the identical answer. That's not a coincidence. That can't be a coincidence. The force pulling fruit off trees in an English orchard is the same force bending the path of a body 240,000 miles away. Same force, same law, operating across a scale difference that should make the comparison absurd. And it works perfectly. You see, the universe didn't have to be this consistent. There was no reason at all, to expect that the physics in your hand would match the physics of the sky. But it does, completely, exactly. And that match, that one number agreeing with another number it had no right to agree with, is the moment physics became something more than observation. It became revelation. So the moon is falling, and Newton's number proves it. But now the obvious question arises, and it's a good one. If the moon has been falling for 4.5 billion years, why is it still up there? Why hasn't it spiraled inward, closer and closer, until it finally completes the fall and hits us? You might think something must be pushing it, maintaining its orbit, keeping it going. Some force outward, some engine, some continuous input of energy that counteracts the relentless pull of gravity. There isn't one. Nothing is pushing the moon sideways. Nothing is maintaining its speed. No engine, no thruster, no invisible hand nudging it along its path. It was set in motion a very long time ago, almost certainly by a catastrophic collision between the early Earth and a Mars-sized body. And since that moment, the moon has been coasting, just coasting. Because here's the thing about space, and I mean really the thing your intuition refuses to accept. Space doesn't push back. On Earth, everything slows down. Roll a ball, it stops. Swing a pendulum, it dies. Throw something, it falls and hits the ground, and that's the end of it. Everything here experiences friction, air resistance, drag, some force that bleeds away motion over time. So your brain, trained on a lifetime of watching things slow down and stop, assumes the moon must also be slowing down, must need something to keep it going, must be fighting against something. It isn't. In space, there is nothing to fight against. No air, no friction, no resistance of any kind. The moon's sideways velocity costs nothing to maintain. It doesn't require energy. It doesn't require upkeep. It just continues because nothing is stopping it. Now this is conservation of momentum, and it is one of the most unsettling truths in all of physics once you really sit with it. You see, motion doesn't need a cause to continue. Only changes in motion need a cause. The moon keeps moving sideways because it was moving sideways and nothing has stopped it. It keeps falling because Earth's gravity keeps pulling. And those two things together, the unstoppable sideways coast and the endless gravitational fall, lock together into an orbit that requires no maintenance, no energy, no attention from the universe whatsoever. It just runs indefinitely, like a clock that never winds down because it was never running on anything in the first place. Newton's law was perfect. For 200 years it predicted everything. The motion of planets, the return of comets, the timing of eclipses, all of it fell into line with mathematical precision that felt almost supernatural. And then Mercury refused to cooperate. Mercury is the closest planet to the Sun, and its orbit is an ellipse, same as the other planets. But that ellipse has a problem. It moves, not by much. The point where Mercury swings closest to the Sun shifts forward slightly with each orbit, tracing a slow rotation that completes itself once every 3 million years. A wobble so tiny it seems like it shouldn't matter. It matters enormously. Newton's equations, when you account for the gravitational pull of every other planet tugging on Mercury, predict almost all of that wobble. Almost. There is a remainder of 43 arcseconds per century that Newton cannot explain. That's a fraction of a degree. An error so small it seems forgivable. It isn't. Physics doesn't do forgivable. An equation that is almost right is wrong, and that tiny discrepancy sat in the data like a splinter for decades, irritating, unexplained, waiting. Then Einstein arrived and did something that should have seemed completely insane. He didn't tweak Newton's equation. He threw out the entire concept underneath it. Gravity, Einstein said, is not a force, not a pull, not an attraction, not something reaching across space from one mass to another. It doesn't exist in the way Newton described. What exists is geometry. Mass bends space-time, the four-dimensional fabric that everything, and I mean everything, moves through. The Earth doesn't pull the moon. The Earth's mass curves the space around it, and the moon, moving through that curved space, follows the straightest path available to it. It isn't being yanked inward. It's coasting along a curve baked into the structure of space itself. See, a straight line through bent geometry looks like an orbit. The moon isn't falling toward Earth. The moon is falling through the shape of the universe that Earth's mass has created. And this is the part that really gets me, when Einstein's equations were applied to Mercury, that 43 arcseconds appeared exactly as predicted. The splinter was gone. Newton wasn't wrong. He was incomplete. He had described the shadow of something deeper without ever seeing the thing casting it. Step back now, all the way back. Look at everything we've covered and let it assemble into something larger. The moon falls toward Earth and keeps missing. The Earth curves space and the moon coasts along that curve. Newton found the number that connected an apple to a world. Einstein found the geometry underneath the number. And every single orbit in the universe, the International Space Station threading silently above the atmosphere, Jupiter's moons cycling around their giant, the Earth itself arcing around the sun, every one of them is the same thing, falling while missing, free falling through curved geometry with exactly enough sideways motion to never arrive. Same phenomenon, same physics, different scales. Now hold that thought and turn it around. Point it at yourself. You are sitting or standing somewhere right now, feeling perfectly still, feeling solid ground beneath you, feeling like the stationary point everything else moves around. You aren't. The ground beneath you is on a rock hurtling around a star at 67,000 miles per hour. That star is orbiting the center of a galaxy at 514,000 miles per hour, sweeping you through space in a path that takes 225 million years to complete. That galaxy is moving through the local group of galaxies, which is itself falling toward a gravitational structure so large it has been nicknamed the Great Attractor. You have never been still, not for a single second of your life, not once. Everything you have ever done, every thought you have ever had, every moment of your existence has taken place on a rock in free fall through curved space-time, coasting on momentum set in motion before the Earth existed, maintained by a universe that contains no friction, no floor, no fixed point to measure stillness against. The stillness you feel is the electromagnetic force in the ground pushing back against the electromagnetic force in your feet. Repulsion masquerading as solidity, free fall masquerading as rest. And here is what should finish the job. There is no bottom. The Earth falls around the sun falls through the galaxy falls through the universe, and the universe has no edge, no anchor, no surface to eventually hit. It's falling all the way down with nothing underneath. Not mystery, not poetry, not a metaphor designed to make you feel small. Just the actual structure of the place you live. Measured, tested, calculated to 11 decimal places, confirmed by every satellite we have ever launched and every orbit we have ever predicted. Newton saw it in a number that had no right to match. Einstein saw it in geometry bending under the weight of mass. Feynman saw it in the question itself, the one that sounds simple until you press on it and find there is no bottom. Why doesn't the moon fall? It does. Everything does. The question was never whether things fall. The question is what they're falling through. And the answer is stranger, older, and more magnificent than the comfortable version you were carrying around. Not comfort, truth. If you want to dig deeper or fact check anything we covered,